Good morning, student. Today in this class I will discuss about a special circuit known as short circuit. Okay, student. Okay. Now suppose I have a student a electrical circuit like this. This battery is connected. Say this is a resistance of 3 ohm and this is a resistance of 5 ohm. This is a battery of 6 volt. Okay, student. Now as you know, you can find out the current through these resistors easily. Now how much is current in this circuit, student? I is equal to V upon R. 2 ampere. 2 ampere will flow in both the resistance. Now student, if I connect a wire across here like this, now how much is the current through this resistor? How to find out? Say by nodal analysis, student. This I am taking it as 0. So this will become 10. This will become 10. This is 0, this is 0. Now this is same wire is connected, conducting wire over here. Now you see, student, the current through this 5 ohm resistor is 0. Because the potential difference across this resistor is 0. And through this resistor current will be how much? See, I have written, sorry, by mistake I have written 10 here, student, 16. Okay. 16 upon 3. This much ampere. So now this student 16 by 3 is current flowing here. Here current is 0. So this current will pass from here. This is known as student short circuit. Means I have shorted this resistance. This is short circuit, student. So if a wire is connected across a resistor like this, it becomes shorted and the current flows through this shorted wire, not this through resistance. Okay, student. Now let's see, student, another case now. Now what I will do, student, in the same circuit, I will connect a battery here, student. Say of 3 volt. Now student, how much is the current through this resistor? Okay. Now again by nodal analysis, this is 0, this is 16, this is 16. This is shorted, student, okay, as before. The wire is same. Now this is 0, then this will become 3. 3 volt. Now student, you see, if I want to find out current through 5 ohm, now the current is not 0, student. Now the current is given by V by R. The potential difference is 3 upon 5. Now this is the current through this resistor, student. Now you have to note, student, current is not 0. This means shorting a circuit simply does not mean current will become 0. Okay, that you have to remember. Now student, how much is current through this resistor? This is 3, this is 0. Current through this resistor is how much, student? I3 ohm. 16 by 3. Now student, see, from here say I1 current is flowing and this current, student, I am naming it as I2. Okay. Now how much is this current, student? See, this is I3. This current is addition of these two. I have applied the junction rule, student. Okay. Now you see the current has changed through this. So this is, student, one of the concept about short circuit. Now let's see another electrical circuit. We have a circuit like this, student. Say 15 volt battery I am taking. One resistor here, 3 ohm, Here we have only a switch S1. Here I have one resistor, say 3 ohm. Here I have another resistor and another switch. This is S2, student. This is 3 ohm. Say this is I am taking 4 ohm. Okay, student. These are the two switch S1, S2. This resistor is 3. I am writing it separately. This is 3 ohm, student. Now in the first case, student, both the switch are open. S1 and S2 both are open. How much is the current? Now this circuit will become, when both are open, this is open, this is open. Now this circuit will become like this, student. Since both are 3, you may not confuse, student. So I am taking it, student, 2 ohm, okay? This is 2 ohm. This is 3 ohm. Now this is the circuit, student. Now you can find out current. 15 upon 5, 3 ampere. So from here 3 ampere. From here 3 ampere. Here no current will be there. It is an open circuit, student. Okay, student, first case. Now, student, second case. Now what I will do is, now I am making S1 closed, student. S1 closed. S2 is still open. Now, student, how much is current? Here now, this is not 3 ampere, I am rubbing it, student. Now how much is the current, student? Okay. Now let's do by nodal analysis. This is 0. This is 15. This is 0 means this is 0, 0, 0. Now this is the same wire, conducting wire. This is also 0. If this 0, then this also becomes 0, student. Now you see how much is the current, student. This is open. This resistor current will be 0. No current can pass. Potential difference is 0. Now how much is the current through this circuit, student? See. 15 V upon R, V by 3, 5 ampere. 5 ampere current is now flowing through this. Here in this resistance current is 0. Now, student, one confusion which comes generally is, see, if I see this resistor, okay, and if I apply Ohm's law, so it is I is equal to delta V by R. So delta V is 0, R is 2, the current is 0. But if I see this case, student, in this is a conducting wire. In this case, if I apply this formula, delta V by R. So delta V is 0, okay. But in this case, student, R is also 0. So 0 by 0, remember, student, means in this case, you cannot find out I by this formula. This is something different, okay, student. And how you have found out this current? From here, current from here is 5 ampere. This current is passing through this because there is no place for the current to pass here. So for this kind of situation, student, you cannot apply this formula. See, 0 by 0 is not 0. Some means to find out current through this, different method is there. You cannot find out by this method. So this confusion comes to the student. Okay, student, it is clear now. Now, student, I am making this S2 also closed. Now what happens? One more thing, student, by closing this S1, actually I have shorted this resistance. And so current became 0. Now, student, I am both the switch are closed. This is also closed. This current I am rubbing it, student, now. Now, student, by nodal analysis again you see 0, 0, 0, 0. Here also 0. Again you see, student, the current through 4 ohm is, now again it is 0 because see, the potential difference is 0. Here already 0, no current. Again the current will pass through this wire only. So now, student, how much is the current? Again 15 potential difference upon 3. So this is 5 ampere. This current will flow from here. So this is, student, the concept about shorting the short circuit, student. Okay, you have to remember about the nodal analysis and how the current becomes zero. In some case current may not be zero, as I have shown you, student, in the previous question. Okay, student. So today, student, we have discussed the basic concept about the short circuit. Thank you, student.